So when you hear the term solar storm, what's the first thing that pops into your head? Probably satellites getting zapped way up in orbit, right? But what if I told you the real danger is much, much closer to home? That those same cosmic particles from the sun can quietly sabotage the technology we rely on every single day, right here on the ground. Let's dig into this invisible threat.
Welcome back. This is part 4 of our 5-part series, and for this one, we're diving deep into a fascinating report by RFI detectives. They've laid out exactly how our ground-based systems, the very foundation of modern life, are surprisingly vulnerable to what's happening in space.
So yeah, I'm going to ask again, you still think this is just a problem for astronauts and satellites? The truth is, these high-energy particles from the sun, they don't just stop at the edge of our atmosphere. They make it all the way down here, and they can create some serious chaos in the most unexpected ways.
Now, the little troublemaker behind all this is something called a single event upset, or an SEU for short. Just imagine a particle from the sun as this tiny, invisible cosmic bullet. When it smacks into a microchip, it can flip a single bit of data. A 1 becomes a 0, or a 0 becomes a 1. It's basically a cosmic typo. The hardware isn't broken, but the software gets corrupted, and that can cause the whole system to go haywire.
And if you want to see this in action, there is no better example than our most critical piece of infrastructure, the electrical grid. Let's take a look at what happens when these cosmic typos start hitting the very systems that keep our lights on.
A lot of you probably remember the huge 1989 blackout in Quebec. We're talking millions of people in the dark for 9 hours. Now, the main cause was pretty obvious: massive geomagnetically induced currents, GICs, that literally fried the transformers. But it turns out that wasn't the whole story. Investigators found that something else, something much sneakier, was happening at the exact same time.
So while these giant transformers were physically melting down, the grid's digital brain was also getting scrambled. The protective relays, think of them as the grid's smart circuit breakers. They started acting weird. Some tripped for no reason, others failed to trip when they absolutely should have. The analysis after the fact pointed the finger directly at SEUs messing with their microprocessors. It was a chilling discovery, a two-front war against the grid. A physical attack from the currents and a digital one from cosmic particles.
And this brings us to this wild modern paradox. You see, the old grid was all electromechanical. It was clunky, it was inefficient, but boy was it tough. Today's smart grid, on the other hand, is this amazing web of digital efficiency, all run by these complex networks. But that very smartness, its total reliance on tiny circuits and software, has made it way more vulnerable to these invisible little glitches from space.
So the problem today is just bigger. A single bit flip inside a SCADA control system, that's basically the grid's command center, could lie to an operator. It could say a circuit breaker is open when it's really closed. I mean, can you imagine trying to manage a power grid with flat-out wrong information? It's not just that. Glitches can mess up real-time monitoring. They can throw off the crucial timing signals that keep the whole grid in sync.
And look, this isn't just a power grid problem, not at all. This invisible threat has ripple effects that touch all kinds of other critical systems that we depend on. Take our railway systems, for example. They are super automated, with safety being priority number 1. While the report we're looking at details incidents where railway signals just started going into false states for no reason. Think a green light that should have been red. And guess what? These events lined up perfectly with solar particle storms. Now, thankfully, safety systems kicked in, but these glitches still caused major delays and forced people to take over manually, showing just how fragile these automated systems can be.
And that brings us to the real heart of the matter, what you might call the smart infrastructure paradox. The smarter and more connected we make everything, the more we're accidentally opening it all up to a threat from 93 million miles away.
Seriously, just think about it. Every single smart device, every sensor, every little controller we add to our world, it's another potential target for an SEU. The Internet of Things is basically creating this gigantic digital attack surface for space weather.
And we're not just talking about your smart home thermostat here. No, we're talking about the controllers running water treatment plants, the sensors that monitor natural gas pipelines, the whole digital fabric of our smart cities. A ton of these devices use cheap, commercial-grade chips with zero radiation protection. Every single one is a new potential weak link in the chain.
The real danger isn't just one device failing. As the source material makes crystal clear, in our super-connected world, a single bit flip in one critical controller could cascade through the whole network, causing a chain reaction of failures in other systems that rely on it.
Okay, I know that all sounds pretty intense, but here's the good news. We are not helpless here. Engineers are totally aware of this threat, and they are coming up with some really clever ways to build, essentially, digital shields to protect our most important stuff.
The experts recommend a 4-part defense strategy. First, you've got to understand your risk. Figure out where all your weak spots are. Second, we need better monitoring to actually see when these particle strikes are causing glitches. From there, we can strategically toughen up the most critical hardware. And maybe most importantly, we can build smarter, more resilient software. And that software part is where it gets really cool. We can use things like error-correcting codes in memory that can literally find and fix those cosmic typos as they happen. We can use watchdog timers that automatically reboot a system if it gets stuck. We can even have software that constantly scrubs its own memory looking for errors, or runs the same math problem 3 times and takes the majority vote to make sure the answer is right. It's pretty genius.
So, as we start to wrap this up, let's just come back to that main idea. Our incredible technological progress, the very thing that's given us smart grids and automated everything, has kind of by accident created this massive systemic vulnerability. We've built a world that runs on microchips, and it turns out those chips are sensitive to what the sun is doing.
And that leaves us with a really huge, important question for our future. By connecting everything, by making our world so deeply intertwined, are we accidentally engineering a global single point of failure? One that could, theoretically, be triggered by one really big solar storm. It's something we have to think about.
Understanding this risk is absolutely the first step towards building a safer, more resilient world. A massive thank you to RFI Detectives for their incredible report that this was all based on. Thanks for tuning in, and we'll see you for the final part of our series.